basics may be known to you about the sets, relations, functions and all, but still we'll see. So what is meant by a set? Can you see the board clearly? Or is it blurred?
Blur, ma'am.
Now also it is blurred.
Now it's clear.
So what is meant by a set? So set is a collection of well-defined objects or a well-defined collection of objects. And why do we stress that it should be well-defined? Can you give me an example of a set? Set of odd numbers, okay. Yes. Numbers. So if I that set of all intelligent students in the class, will it be a set? Someone please mute. Yeah, if I tell that the collection of all tall students or intelligent students in the class, then will it be a set? Is it a set or not? It is not a set. What do you say? Is it a set or not? It is not going to be a set. And what is the reason? The reason is it is not well-defined collection. Okay, that means that this definition will change according to different people. Like according to me, I'll say one set. So I might think that the student may be intelligent, but you might think that is not intelligent. Okay, so according to different perspective, if that collection differs, then it cannot be
all can be intelligent, but the IQ level can't be same for all.
Okay, so the thing is, if we want to define the intelligence, we should tell some factor, right? Like you said, the IQ level. So if I say if I simply say intelligent, that means I might say that some students are intelligent in the class, but according to you, some more students might be intelligent, right? So it is, the definition is changing according to the person. So it cannot be well defined. Understood? But set means whatever whichever student or whichever person you ask, the answer should be the same. Then it is called a well-defined collection. Okay, if I say set of all x belongs to n such that x is greater than 5 and x is less than 10, then what will be the answer? Then what is going to be the answer? What will be the set? X belongs to n such that x greater than 5 and x less than 10.
6, 7, 8, 9.
6, 7, 8 and 9. And I ask the same question to anyone, they will give me the same answer, right? Because it is, everything is defined here. X belongs to n. That is, it should be a natural number. And it should be greater than 5 and less than 10. So this is an example of a set. Okay. But suppose if I didn't define here that x is coming from where, then it is not defined. Okay, it is not well defined collection. So I should define it properly. Then only I can call it as a set. Because if I instead of n, if I write r here, then what happens? Then what will be the answer? x belongs to R, x is greater than 5 and x is less than 10. Then it is going to be the interval 5 to 10. Am I right? It is going to be a subset of set of real numbers, and that is nothing but interval. It has infinite number of elements. Okay, but if you mention set of natural numbers, then it is a finite set. So according to the definition, only we can say that a collection will be a set or not. It should be well defined. We can represent the sets in two ways. One is called the roster form and one is called set builder form. These are the representations of set. So roster form representation means when we write down all the elements, when we list out all the elements separated by commas, like this, like for example 1, 2, 3. This is a roster form representation. And set builder form representation means we won't write down every element, but we will give a general form of the elements. Like I will express it as set of all x such that x satisfies a given condition. Like for example, set of all x such that x is a vowel in English alphabet. So that is a set builder form representation. And can you tell me what will be the corresponding roster form? Set of all x such that x is a vowel in English alphabet. So what is going to be that set? A, E, I, O, U. Okay. So these two are equal sets. Just that representation is different. Here I have represented it in the set builder form. That is in this way. Set of all x such that x is satisfying some condition, and that is x should be a vowel. And this is the roster form. That is when I list out all the elements separated by commas. That is called roster form representation of a set.
Ma'am, this A, E, I, O, U is roster form.
Yes, it is roster form. Roster form means you list out the elements, list out all elements within curly braces or curly brackets separated by commas. Okay. Now next is the types of sets. So inside the set, tell me one more thing. When we did sequences and series, I had told you one thing. The difference between sequence and set. What was the difference? You remember?
Sequence follows an order.
Yes, very good. So in sets, the order and repetition is not important or doesn't matter. Order and repetition doesn't matter while defining a set. But that is important in sequences. And its meaning is if I write 1, 2, this set is same as 2, 1. And it is same as 1, 1, 2. Okay, like that you can write many equivalent forms of the same set. So here 1, 2, I changed the order. But it is the same set. Here repetition is there of the element 1, but still it is the same. So order and repetition doesn't matter while defining a set. Now what are the types of sets? So first is empty set or null set. And we denote it as 5 or like this. And what is empty set or null set? The set does not have any element. Then second is singleton set. So singleton set means the set has a single element. Only one element will be present. Then third is finite set. The set that has finite number of elements. Then infinite set. The set that has infinite number of elements. What are the infinite sets you know? The sets of different numbers. First one we will learn is the set of natural numbers, and that we denote it as like this. Okay, set of natural numbers is an infinite set, and that is 1, 2, 3, 4, etc. So it is the counting numbers. Then second one is the set of whole numbers. That is, along with this, we will put 1, 0. That is the set of whole numbers. Then next comes the set of integers. Then after that, what is the next set of numbers? After integers?
Rational number.
Rational numbers, yes. Rational numbers, we denote it as Q. And how to represent the rational numbers? So here we will use the set builder form representation. That is set of all x such that x can be written in P by Q form. Where the P and Q are coming from set of integers and Q not equal to 0. Okay. So any number that can be written as P by Q form, and the P and Q should come from set of integers and Q should not be equal to 0. Because Q we write in the denominator. If it becomes 0, then that will be undefined. So all those elements comes under the set of rational numbers. Now what is the next one? After that, set of rational numbers. So what happens if some element is not belonging to the set? Like let's say 1 by root 2 or root 2. So is it a rational number? That is, you just need to check whether it satisfies this condition given. It can be written in P by Q form, yes, but P and Q should come from integers. So P is 1 and Q is root 2. Is it an integer? No. So that doesn't belong to the Q. So for such numbers that does not belong to Q, we create Q complement. That is the set of all irrational numbers. And that is set of all x such that x is not rational. The numbers that are not rational, you can include in the Q complement. Okay. Then what is the next set? It is a set of real numbers. So set of real numbers, that is nothing but Q union Q complement. That is collect all the elements of this set and this set. That is set of all rational and irrational numbers. Then is there any other set? Next.
Complex numbers.
Set of all complex numbers. So why it was necessary to introduce this set of complex numbers? Do you know the reason? Was this set of real numbers not enough? Why did we introduce set of not we? Why the scientists introduced set of complex numbers? So they were stuck with some equations like x square plus 1 equal to 0. So when they searched for the solution, they could not find it in the set of real numbers. Okay, what is the solution to this? X square plus 1 equal to 0. So x will be plus or minus root of minus 1. Okay, and this root of minus 1, it is not a real number. So any real number, if root x is a real number, then that implies that x should be greater than or equal to 0. Within this root, this x should be greater than or equal to 0, then only this root x will be a real number. So then what happened is, they had to introduce some numbers called imaginary numbers. So the imaginary number they denoted as iota, and they defined it as root of minus 1. Then this is called, so then the solution to this equation is plus or minus I. So there should be some set to accommodate these imaginary numbers also. So along with the real numbers, they added the imaginary numbers and combination of real and imaginary numbers, and that is called the set of complex numbers. Set of all real numbers and imaginary numbers. And how the elements will look like inside this C. So it will look like set of all sum A plus IB or x plus IY, such that the A and B are coming from set of real numbers. If the B is 0, then we will get all the real numbers because A is coming from R. And if A is 0, then all the numbers will be purely imaginary. Purely imaginary means only imaginary part is there. And if A and B are non-zero, then it will be like A plus IB form. So these are the sets of numbers, and all these are infinite sets. And what about how can we find out the number of elements in these infinite sets? If it is finite set, then we can find it out. Like if I say A equal to A, B, C, D. Now, if I ask you what is the number of elements in A, or number of elements is also called the cardinality of a set. Okay. So you can denote it as in this way, n of A, or like this. Okay, or cardinality of A. In that way you can define, and that will be just, we can just count how many are there. Total 4 are there, so you can tell the count. But what if I take one infinite number and ask you how many elements are there inside that? Then what can you say? So infinite numbers, it is not possible to count. Okay. So, but there is another way to talk about their cardinality. And then we will introduce what is called the countable and uncountable sets. Okay, when in infinite set itself, there are two types. One is called countable and one is called uncountable. And we will see all those things in a while. You can see this question. This was one task in TIFR exam. It is a very easy question, basic, but many students they got it wrong. Which of the following are sets? Option A, B, C. Then option B, A, B, C. Option C, 1, 2, 3. And option B, 1, 2, 3. Then A, B, C. This can be, answer can be more than one answer correct. So which of the following are sets? That is wrong. Not C and D. All. That is also wrong. So I'll tell you what is the concept here. The answer is A and D. Here, the thing is, you look at these dots. Okay. Other than the dots, if the dots count is 3, then everything is correct answer. So if you look in standard textbooks, you can always see that whenever they write the dots, always it will be 3 in number. That has a definition like and so on. That means whatever we started with, that same pattern is going to continue. Like 1, 2, 3, then and so on till 10. Okay. So based on that, so every time it should be only 3 dots. But when we write, we just put like many dots as we like. But in a standard way, if you see only 3 dots, so here it is correct. A, B, C, and so on N. So till N you have to write. So this is the alphabet they are writing. Now here also, but here 5 dots are there. Here 4 are there. And here it is 1, 2, 3 till 10. And A, B, C till Z. So that is also correct. So option A and D are correct. So just write it down.